Good morning, everyone. Today we're going to be looking at lesson 110, which is going to be our very last lesson for this school year. I am very excited about that. I'm sure that you are too. We're going to be talking about simple interest and compound interest and successive discounts. I know right now that might seem a little bit foreign to you, but by the end of the lesson, you'll have a good understanding of how you can make some money for yourself and also how to understand savings on different items. So I want you first of all to make sure you have your lesson printed and in front of you. Half of your grade on this lesson is coming from page 1. You're going to notice there's going to be a lot of notes on here. So the first page is actually worth 7 points, and then when you get into your book problems, there are going to be 8 problems. So the backside is worth 8 points. The total lesson is worth 15 points. And keep in mind, I just want to make sure you're aware that good note taking will be worth almost half of your points on your lesson. So just make sure you're doing that. Also, I'd like you to have a calculator somewhere nearby. So if you can go run and get a calculator, you can pause this. And I'm going to write here to use a calculator. For some of this, we're going to be doing that. I want to show you how to find a compound interest, and a calculator is a really nice, easy way to do that. Alrighty, so let's go ahead. We're going to cover some of these terms up top. So let's go ahead and fill those in. We're talking about money in a bank right now. So if you were to make a deposit, I don't know how many of you have savings accounts, but if you do, you should receive a statement from your bank, maybe on a monthly basis, maybe on a quarterly basis. And you'll see there, you can see the money that you've deposited in the bank. And then you should also see where they've paid you some interest for holding your money for you. They actually use your money in the bank. That's what they use to make their loans with. And so they pay you interest as they charge people interest who get loans from them. So anyway, we're going to talk about more specifically how this pertains to you. So we need to understand what the principal means. The principal is the amount of money that you deposit into the bank. Interest is the amount of money that the bank pays you. There's 2 types of savings accounts that I want to talk with you about today. There are many out there, but typically interest is paid in one of 2 ways. You might have a simple interest savings account, which you won't make as much money on as you would a compound interest account. And compound interest is actually the most common because people want to make more money than less money. So most of them will find a savings account that will pay compound interest. So let's go ahead and write in what simple interest is. Simple interest is the interest that is paid on your principal only. So what you deposit in the bank is what you're paid interest on only. We're going to look at an example in just a few minutes of when you have money in the bank. Say we're going to look at 3 years worth of interest on a simple interest savings account, and then we're going to check it out next to a compound interest and see the difference of earnings there. A compound interest is interest that's paid on your principal, but not just the principal, also on any accumulated interest. And lastly, we're going to talk about successive discounts. Right now, we're just going to fill in what that means. That's going to require a little bit more teaching to understand what that is. But a successive discount is when you have more than one discount that is calculated by finding the percent of a percent. And you might think that sounds a little weird, because without understanding how it works, it kind of does. But we will get there towards the end of the lesson. We'll get a little bit more explanation for that. But let's go ahead and look at our first example here. So let's say that you deposit, I'm right here. Let's say you deposit $100 in an account that pays 6% interest. And we want to see how much you're going to earn in 3 years' time. If you had a simple interest savings account, and then we're going to look at how much you make if it was a compound interest savings account for 3 years. So I'm going to blow this up here a little bit. Let's look at the simple interest first. All right, so you're going to deposit $100 into your account. You're going to earn 6% interest is what we were told up here. 6% interest. Well, we're going to multiply. You know how to find an interest rate amount. If you know the percent, we can turn that percent into a decimal, and 6% is written as 6/100ths or 0.06. You would multiply that, and you can figure out how much interest that you would have after the first year, and your deposit has remained in your account for the full 12 months. You would get $6 in interest. At the end of the year, now you would have $106 in your account. On year 2, you're going to earn the same amount of interest that you did during year 1. At the end of the year, you'll have earned another $6. Okay, so now you would have $112 in your account. The third year, it pays the same exact amount. You're going to earn $6 in interest in year 3, and now you have $108 total. What have you earned in interest? You have earned $18 in interest, and your total in your account, let's put a line right here, is $118. Okay, that's your simple interest, the balance in your account after 3 years' time. And that's provided your $100 has sat in that account for those full 3 years. Now let's move over to the compound interest, and you're going to see how this works a little bit differently. Year 1 is paid exactly as it was in your simple interest account. You're going to earn at the end of 1 year or a full 12 months, and provided your $100 stayed in your account, you're going to earn $6. And so now you have in there $106. Year 2, we're not going to pay it on the bank doesn't pay it just on that principal amount of $100. It's going to pay you now on how much money is actually in your account. So in year 1, after you were paid your $6, you now have $106 in your account, and compound interest means they're going to pay your interest on your principal and the accumulated interest, which was $6. So now they're going to pay interest on your full $106 that's in the bank at 6%. After year 2, you're going to earn $6.36, and now you're going to have, you had $106 in there, you just earned $6.36 more, and now your balance at the end of year 2 is $112.36. Year 3, they're going to now pay you on your new balance, which was your principal and all your accumulated interest. So now they're going to pay you 6% on your $112.36. So your amount of interest paid at the end of year 3 is $6.74. So if I add that to the balance that was there at the end of year 2, now your new balance is $119.10. So your total at the end of 3 years being paid 6% compound interest is $109.10. Now you might look at those two amounts and think it's really not that much of a difference, but I'm going to show you where it actually does pay off to be a big difference. I have down here at the bottom, and this is actually in your book. You could find this on page 763. This is the same problem that we just did. You notice that at the end of 3 years, right here is what we did. I'm going to change my color here to yellow. Okay, so we saw that your simple interest, which is here, versus your compound interest here. We had $118 at the end of 3 years being paid simple interest, and then the compound interest account paid us $119. We ended up with $119.10 at the end of our 3rd year. Look at the balance in 10 years. All right, so simple interest at the end of 10 years, now your principal and your interest together totals $160, and your compound interest account would have accumulated $179.08 with your principal and your interest paid there. At the end of 20 years, you have $220 in your simple interest account. you would have $320.71 if you had put it into an account that pays compound interest. Look at the end of 30 years. Now you're starting to see some jump here. $280 in your simple interest is what you would have at the end of 30 years on that $100 that you put in year one. And on your compound, if you had compound interest being paid, you would be up to $574.35. After 40 years, look at that, $340. This is a huge jump. If you had simple interest and you put that $100 in there at the beginning of year one, by the end of 40 years, you would only have $340 in there. But being paid compound interest, where you're being paid interest on your principal plus all your accumulated interest, you're all the way up to $1,028.57. And then finally, after 50 years, you can see the big jump here. $400 is what you would have in a simple interest account, and your compound interest account would have ended with a balance of $1,842.02. That is more than 4 times the amount of what you would have in this account. So obviously, this is the way to go, and most people want to do that because our goal, if we're going to save money, is to put it in an account that pays the most. All right, so that's simple and compound interest. Now you see the difference of how that works. Let's go down to this example 1 right here. We're going to make a table that shows the value of a $1,000 investment that's going to be growing at 10% compounded annually after 5 years. Okay, so the first year, second, third, fourth, and fifth years. So let's go ahead and fill those years in right here in the chart. So we're going to have in our table year 1, 2, 3, 4, and 5. All right, so you put $1,000 in. Let's look at the first year. So you put the first year, you dumped into that account $1,000. You're going to be making 10% compounded annually in your interest. So we would multiply that with 10%, which we know as a decimal is 0.10. If you did the math there, you're going to end up with $100 in interest. So your balance at the end of first year, that first year is going to be $1,000 plus the $100. So you would have $1,100 at the end of year 1. Okay, now this is compounded. So we're going to be paid the second year. At the end of the second year, your interest is not going to be paid on $1,000. It's going to be paid on your principal plus that accumulated interest of $100. So it's going to be paid on $1,100. It's going to be paid on this amount. Okay? So it's $1,100 times your 10%, and you're going to earn $110 in year 2. And if I add this with this, I'm going to end up with $1,210 at the end of year 2. Let's keep this pattern going. Now I'm going to be paid interest on $1,210. And at the end of year 3, I'll have earned another $121. So I add $121 to my balance of $1,210, and I end up with $1,331. I hope you're following me here on this. So at the end of each year, whatever interest I make, I add that interest to the balance of the end of that year. So let's look at year 4. So now I'm going to be paid interest on $1,331, and I end up with $133.10. I'm going to add this to the end of year 3's balance, which is going to give me $1,464.10. Oops. And then finally, for that 5th year, I'm going to be making 10% interest on the balance that I ended with in year 4. And that amount is going to be $146.41. I'm going to add that to my balance at the end of year 4. And at the end, so that the end of year 5, I'm going to have $1,610.51. Okay, so that's a pretty good bump. The difference there is about, what, $500 little over $500 I made in 5 years. That's not too shabby. All right, now I want to kind of show you something here. This is going to be very interesting. At the bottom, we're going to write a note here. And that note is, let me say it first. Year one, the amount, I want you to think about this, the amount that I actually, how do I want to say this? Let's do year one, the amount, and you know what, I'm going to draw a line here to just kind of encompass this into that area. The amount is 110% of the original deposit Okay, so what do I mean by that? Year one, the amount is 110% of the original deposit. So look at my amount in year one. In year one, my amount was $1,110. That is 110% of my original deposit. So how do I figure that? Well, my deposit was $1,000 and then I made $100. So the deposit that I put in there, the $1,000, was 100% of my principal. And then the $100 that I earned in interest is the additional 10%. So that together is 110%. Now let's think about that 110%. Whoops, that's not to be a dollar sign there. Oh, gracious day. Hold on a second here. Year one, A-M-O-U. I got to stick a U in there. There we go. Okay. So let's write right here 110% as a decimal. Remember, we just moved the decimal point back 2 places. So as a decimal, we write 110% as 1.1. Now I'm going somewhere with this. All right, now I want you to grab a calculator. I had to redo, I was recording this earlier, and I tried to go grab my calculator where I'm actually recording on my iPad, but once I actually put this document aside, it stopped the recording. So I don't know how to bring a live working calculator into this app. So I'm just going to have to talk through it with you, and maybe tomorrow I can show it to you. Well, not tomorrow, this morning, because by the time you see this, it will be morning. Perhaps I can show you the calculator there. But if you can follow me on this, it'll be fun to kind of see this. So in your calculator, you're going to plunk in there 1,000. Okay, and then you're going to multiply it by 1.1. And I'm going to do that here on my calculator. I'm going to put in 1,000, and I'm going to multiply it times 1.1 and hit my equal sign. And you see that that gives you $1,100. That's your first year's interest and principal together. Now, there are 4 more years that we talked about. That was year one, $1,100. Now I want you to hit your equal sign 4 more times to represent year 2, 3, 4, and 5. So right now you have $1,100 sitting on your calculator. Hit the equal sign 4 more times. I'm doing it too. 1, 2, 3, 4. Now look at that balance in your calculator and look at that balance at the end of year 5. Okay, so that's just an easy way to calculate your interest rather than having to do it by hand. So down in this note for calculator, I want you to show here that you would hit 1,000 times 1.1 and you would hit equals. And then you're going to hit it 4 more times. Yep. So we'll put, actually we're going to have to write 5 little equal signs here. Okay, and that's going to give you your ending result of $1,610.51. So I hope that makes sense to you, and we're going to get a chance to use that over in the next example. Okay, so let's go on over to example 2. We're going to use your calculator for this problem to find the value after 12 years of a $2,000 investment that earns 7.5 100% interest compounded annually. Okay, so I want you to make a couple notes before you actually do this. So we're going to use 107.5%. Remember, let me bump over here real quick. Remember, right down here where I explained to you how we came up with 110%. That first year is 110%. So that's what it's increasing. Okay, so over here, we take the 100% of our principal, and then on that, we have to add to that our 7.5% that is going to be our interest amount. Okay, so that's how we come up with the 107%. I'm going to change this to 107.5% because I want you to see that we're going to move the decimal point back to get our decimal number where we can drop our percent sign off. So if our decimal point goes back 2 places, then our rate is 1.075. And that's the rate we're going to use to multiply. So now on the calculator, write this in your notes. You're going to put in $2,000 times 1.075 equals, but you're going to hit, and I'm going to put in parentheses here, you're going to hit the equal sign 11 more times. And let's see what you get. Why 11 more times? Because the first equal, remember there's 12 years here. And the first equal sign is for year 1. This one right here is for year 1. The next 11 is for the next 11 years. So get your calculator and let's go ahead and calculate that and see what you come up with. I'm going to do it on my end. You're going to do it on your end. So we'll put in 2,000 times 1.075 equals, you got to keep track now, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. You should have come up with quite a few numbers there. I'm going to write down what I got. You check and see. If you didn't get this, then you might not have hit your equal sign enough times, or you might have hit it too many times. But you're going to get 4,763.5592. So we're going to round that to the nearest cent. So you would have 56 cents. If it didn't turn out, try it again and see 2,000 times 1.075 and hit your equal sign actually a total of 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, it works out perfect. So hopefully that worked out for you. If it didn't, we'll talk about that on our Zoom call today. All right, let's move down to example 3. Now we're going to calculate the interest earned on $8,000 in a deposit that's in there for 9 months if the annual interest rate is 6%. Okay, now we aren't even making a full year here. That's a big difference because you'll notice up in the other problems, we knew that it was in there. It was compounded annually. Like look up here in example 2. I just highlighted the word annually. In example 3, it's not even in there for the full year. So we have to figure out how to calculate the interest. Normally, when you calculate interest, it's annually. So you would just multiply the 0.06 interest, and that's going to be your interest because it's for the full 12 months. But in this case, you're only going to be getting interest paid on 9 months, so it's going to be a little bit less than what you would get for a year. So let's write down $8,000. We're going to multiply it by our 6%, which is 0.06. You can use your calculator for this. I'm going to use mine. 8,000 times 0.06, and I would get $480. That's what I would get if it were in there for the full year. Okay, because look, the annual interest is 6%, but it's only in there for 9 months. So I need to multiply this by a fractional part of the year. If it's being paid on 9 months out of the full year, my fraction then would be 9 months out of 12. I could do some cross canceling here, so I'm going to do that. Okay, so I cross out my 12 is 1, and my 480 would become 40. And I would end up with $360. So if I had needed my money and I was going to pull it out after 9 months, I would have earned $360 on that $8,000 that I deposited. Okay, so that's not too bad. Okay, now that's all we're going to say about simple and compound interest. Now we're going to go down to the bottom and look at what successive discounts are. Okay, now let's read the problem here. I was trying to blow it up, but I can't really do that without losing part of the problem. So example 4 says, an appliance store reduced the price of a $400 washing machine 25%. When the washing machine did not sell at the sale price, the store reduced the sale price again, another 20% to its clearance price. What was the clearance price of the washing machine? Okay, so there's 2 ways that we can solve this. And the first way we're a little bit more familiar with, we use ratio boxes. So in the first one, now I'm kind of going to go down here though. I'm going to draw a little picture for you. I know how much you guys love my artistic work. I'm going to draw you a little washing machine here. It always has like a back panel on it, and it might have some dials up here that you turn. If it's a front loader, you're going to have a big circle right here, and you might see like your little shirts spinning around in there. Okay, so there's your laundry machine. What you need to realize about this is it had a regular price. We know that according to the problem, the original price of this thing was $400. Okay, that's the original price. We know that they're going to take off 25% in a discount if you buy it today, right? Okay, but that would mean then that we would actually be paying for 75%. So the sale price is actually 75% of the original price. Okay, that should make sense. So let's go up into our ratio box. Let's fill that in up here. All right, we always know that we put the 100% up top. We start with the original price. We know the original price is $400. We always put our change right here. And in this case, it's going to be subtracting because it's a discounted amount of 25%. And then our new price, which is going to be the sale price, and I'm going to put that in parentheses here, is going to be 75%. So if I bought that machine on a discount, I would only be paying 75% of the original price. I don't know what the discount amount is, and I don't know what the sale price is. But we are to figure out what the sale price is, and we're going to call that S. All right, so we're going to go ahead and solve for the sale price here. We're going to set up our proportions, 100 over 75, and keep in mind, if I'm looking for the sale price, I have to use this as part of my proportion, and then I go and I find where I have numbers in both of the rows, or columns rather, and that would be my original information up there. So I set it equal to 400 over S. I do my cross products here. I'm going to end up with 100S equals 400 times 75. And I will end up with 100S equals, that turns out to be 30,000 right here. I divide both sides by 100. I have some zeros I can cross off, and I end up with, I don't want to write too far down here, $300. Okay, so the sale price is $300. I'm going to highlight that. That's my sale price. Now let me go back down to my washing machine. The thing of it is, the store didn't sell it when it was on sale. People came in and they didn't want to pay that. So the store said, all right, then I'm going to discount it even further. I'm going to put it on clearance. Maybe if I put a clearance price on it, maybe this machine will actually sell. So what the problem tells us here now is that, I'm trying to find here what it said, sale price 20. Okay, so now the store is going to reduce it another 20%. So let's think about this. We are now going to take, you have to ask yourself, what is he discounting it off of? Like, what is the price he's going to take the additional 20% off of? Well, it's going to end up being, and I want to write down here, what did we get? We said that the sale price was $300. So let me write that right here. Okay, so now our new price was $300. And he's going to take 20% discount off of the original discounted price or sale price. And when he does that, now we're going to pay 80% of the discounted, the sale price. Remember, this was the sale price. So now we're going to pay 80% of the sale price, and this is going to be our clearance price. So now we have to figure out what that is. So let's go back up to our ratio box and fill this in. Okay, so now we said our original is always going to be 100%, but in this case, it's $300. Okay, because we're going to discount the sale price. The sale price was $300, so it's like a second discount. We're going to subtract the change, which is 20%, and our new price is going to be 80%, which is actually our clearance price. Okay, and I don't know what the change amount is, and I don't know the clearance price. But what we're supposed to find out is the clearance price, and we're going to call that C. So let's set up our proportion again. So I have this amount, and I have this amount, and I need to find the clearance, so then I need to use the 80. Alrighty, so let's set up our proportion. So I have 100 over 80 equals 300 over C. And if I do my cross products, I have 100C equals 300 times 80, which is going to be 24, 1, 2, 3 zeros. I divide both sides by 100. And I end up with $240 as my final clearance price. Now, maybe someone will be more interested in that machine thinking that originally the price of that thing was $400, and now it's down to almost half that cost, which is an amazing deal for someone. Okay, now that's the first way that we can solve using two ratio boxes. It's a really nice way. The method is good because it organizes your information in a table and you can keep track of what you're doing. But method 2 can be easier for some brains to process. So this is where, if you remember up top, I said that a successive discount over here at the very top is when there's more than one discount and is calculated by finding a percent of a percent. Well, do you realize that that's what you did down here? When you calculated this particular one, you found a percent of a percent. That's what we did. So let's see how that works out. And I want you to write here, right next to method 2, I want you to write, this is when you would take, and you can just kind of abbreviate or use the symbol for percent. We're going to take a percent of a percent. That's what we're going to do in method 2. So we're going to jump to finding the clearance price right off the bat. All right. How do we do that? Okay, well, let's think about the second ratio box here. In the second ratio box, we took 80%. We took 80% of the sale price, right? So over here to the right, I'm going to write 80% of the sale price. That's how we find the clearance price. What was the sale price? The sale price was 75% of the original price. Go back to your ratio box and look at that. The first ratio box shows that the sale price was 75% of the original price of $400. So to find the second discount, we have to know the sale price. How did we figure that out? Well, that was 75% of 400. So now I'm going to rewrite this 80% down here as a percent of a percent. So look at that. So we're going to take 80% of 75% of 400. Okay, so kind of keep this thought together. Now let's just turn these into decimals. So I have 0.80 of means multiply. 75% is 0.75 of means multiply, and 400. Use your calculator that you have sitting there beside you, and let's do that math in our calculator to make this as painless as possible. So 0.80 times 0.75 times 400 equals $240. So the clearance price is $240. So look at that. Was that a lot easier? You got the same answer with much less work on method 2. But method 1, if you need to organize your information and go one step at a time, method 1 is perfectly fine as well. If you choose to use method 2, you just have to think through the process. So in your brain, you have to organize that information, figure out the clearance price. The second discount is a percent of the first discount. That's what makes it a successive discount. And that is basically all I have for you today. That was a lot of note taking. I hope that you were able to get all that you needed. This will be posted on Google Classroom, so if you missed anything, you can copy it down from there. I will plan to see you on Zoom in just a little bit. Please try to get as much of your lesson done as you can. So if you have questions that need answered, I can help you with that. And I'll see you shortly. Have a great morning.